Okay, am I audible now?
Yes, Saurabh, you're audible. You can go ahead.
Yeah. So, good afternoon, sir. Good afternoon, everyone. This is Saurabh Bera, and I'm looking after the technical sales support from West Zone, India. And the previous information was very much supportive and informative. Now, moving forward, we will start with the fault analysis and solution of grid over voltage and grid under voltage. So, this is here it is. The, what kind of faults or what how does the fault analysis occurs? Here it is. The reason for grid over voltage. Now we see that during normal operation of the inverter, when the grid voltage is higher, or the maximum then the maximum voltage threshold of the inverter grid connection standard, the inverter records grid over voltage fault. When it occurs that the large fluctuations in the power grid cause the instantaneous voltage to exceed the maximum voltage threshold, which the inverter reports grid over voltage fault. And secondly, if the grid connected line is too long or the wiring is not so good, the line impedance will be too large and the inverter will report the grid over voltage fault. As we can see in the below diagram, the over voltage occurs during the grid over connected line is too long and the impedance is very much high, which is too large. This diagram of the over voltage caused by the impedance of grid connected line shows the over voltage occurring fault. This kind of over voltage alarm occurs in the in our inverter display, on our inverter display, where the display shows OVGV01, where the OV stands for over voltage, G stands for ground, and V01, where 01 is the alarm error code. Yeah. So now, for the over voltage alarm, the fault analysis will be the grid connection standard issues. The grid connection standard issues occurs mainly due to the wrong selection of grid connection standard or due to the special situation of the local grid. Here we can see that through the LCD or the grid connection standard value, to view the current grid connection standard, we should first turn off the DC switch of the inverter and the main circuit breaker. And then next we should use the multimeter to measure the phase to neutral line and phase to phase line voltage on grid side, which is the troubleshooting method for our for checking the grid connection standard issues. Now, if the grid side voltage is higher than the normal standard grid connection, the threshold of the inverter, it is the grid side over voltage fault. Here we can see the standard issues and its solutions. First of all, we should, on the inverter display, we should go and check for right standard grid connection standard and reset the grid over voltage value. On our inverter, we have some settings which would help to choose the right grid connection standard. And these are the settings on which our inverter can help us to get the right grid connection standard done. For advanced, we should check for advanced settings on and give the password. Select the particular standard as per the local grid or the grid available in that area, and or consider the help from our service line. Service line executive. We can also set the threshold value of the voltage, frequency, and the reconnection time in turn. Again, other problems which are caused by grid disturbances are the large fluctuations in the power grid, which causes the instantaneous voltage to exceed the maximum voltage threshold of the grid connection standard, and the inverter records grid over voltage fault. Now we can see the inverter has been normally running for a long time, and the problem for which the grid over voltage fault suddenly appears. At that time, we should check for the inverter human machine interface, which is available on our Solis monitoring plant, to check out the historical fault information by clicking on the grid disturbance alarm before the grid over voltage fault, which is available on this kind of interface. Here we can see the grid over voltage fault alarms, and for this troubleshooting method, this is the solution. Solution is we should wait for some time when the power grid disturbances is disappears. The inverters can automatically recover normally. Secondly, the restart the inverter, check if the fault has disappeared. Firstly, deal with the grid disturbance problem according to the grid disturbance treatment method. Then the power grid disturbance problem disappears. Also, the possible causes will be impedance problem of the AC cable. Sometimes it happens like if the grid connected line is too long or the wiring is not so very good, line impedance may be too large and the inverter will report grid over voltage fault. At that time, we should use the multimeter or the clamp meter to measure the phase to line neutral line voltage and phase to phase line voltage of the inverter AC connection port on the grid side. And the situation to solve is the virtual connection occurs on the AC side. Hence, the remake the AC terminal and rewire it. Also, the wire diameter of AC cable, if it is too small, we should reselect the cable accordingly to 1.5 times the maximum output current, so that the impedance problem shall diminish. The over voltage power derating function, as this and this information has been shared from our sir in the previous slides only, and we as the over voltage power derating function in areas with limited grid capacity or the high line losses, high power generation at noon is very likely to cause grid over voltage arms, and frequent inverter start and stop will seriously affect the power generation issue. Hence, through our Solis over voltage power derating function in the poor grid scenario, Solis inverters can run with and without disconnection from the grid, which helps to continue to generate power and increase the power generation revenue. Now, the fault analysis for grid under voltage fault. Similarly, we should update when we see that during normal operation of the inverter, when the grid voltage is lower, very much lower than the minimum voltage threshold or the startup voltage of the inverter grid connection standard, the inverter reports grid under voltage fault. When certain grid phase fails or the power fails, the inverter reports grid under voltage fault. And when the grid voltage is very much uneven, the inverter also reports grid under voltage fault, which occurs due to the loose connections of the AC cable wires. The following image will also be displayed on our inverters like this. It shows like under voltage alarm, where the status shows in the inverter is UNG V01, where UN stands for under voltage. So what are the possible causes? Same, the wrong selection of grid connection standard or the special situation of the local grid. At that time, we should use the current grid connection standard, which is available on the grid on the LCD of the AC cable box, or using clamp meter or multimeter. Immediately, we should turn off the DC switch of the inverter and the main circuit breaker. And using the multimeter, we should measure the phase and neutral line voltage on grid side. If the grid side voltage is lower than the standard grid connection of the threshold of the inverter, it is the grid side under voltage fault. And to correct it, we should use the select write grid connection standard or reset the grid under voltage fault value by using the advanced settings which is available on our inverters according to our according to the right grid connection available in the particular area. Same the same kind of settings for threshold value of voltage, frequency, and reconnection time can be changed using the advanced setting menu available on our inverter. Now, the second possible cause is certain grid phase failure or power failure. As we know that during the normal operation of inverter, sometimes when it happens when certain grid phase fails or power fails, the inverter reports under grid voltage form fault. The inverter or monitoring display displays grid unbalanced fault and under grid voltage fault appears at the same time. At that point of time, we should turn off the DC switch of the inverter and the main circuit breaker too, using the multimeter to measure the phase to neutral line voltage on grid side. If the grid side voltage is extremely low or there is no voltage, it means the grid has caused the phase failure or power failure. And for particular this kind of grid phase failure or power failure, the solution is check whether the AC cable is properly connected, whether there is a missing phase or a certain phase, or wait for some time when the grid phase loss problem disappears. The fault can be automatically recovered. Thirdly, the inform the grid company to wait for the power grid to be repaired. Third possible cause which happens sometimes in undergrid voltage fault is when the grid distribution load is very much uneven. It occurs very much in the rural areas where we can see the inverter or the monitoring display is showing the unbalanced fault and the under voltage fault appear at the same time. Using a power meter or the power analyzer, we should use to measure the load distribution of each phase under the total circuit breaker, which will use the you can also use the multimeter to measure the phase to neutral line voltage on grid side. This troubleshooting method will help us to find the solution, like to read the just the on-site power load, supply distribution, especially the single phase load, which needs to be evenly distributed, and the second neutral line, and the second one is the neutral line on the distribution side, which adopts the multi-point grounding scheme to reduce the neutral line loss caused by the unbalanced loads, which will help to check for uneven grid load distribution. Third, we can use an oscilloscope to detect the grid voltage and give the detected voltage waveform to Solis, to our Solis team, to give a particular phase and specific solution. This distribution is uneven, hence to report we should, if the solution is, if the particular problem or the cause is not getting solved, this can be handed over to a Solis service team, which will help in order to give a particular specific solution. I hope the particular presentation was very much audible and clear. If any questions are there, you can ask in the chat box. Thank you.
So let's take some of the questions what has been put it by the customer. Let me open the chat box. Imran Hussaini has raised why every time error shows OVG grid 5. See, it's there are particular levels 1, 2, 3, 4, and like sometimes when the grid voltage is too beyond the range of the inverter, and if it is going some periodically, so and if it is hitting to that level, inverter would show this particular alarm. You can get in touch with our service line people. They can guide you, and they will give you the troubleshooting point, and that can help you to solve this problem. how much the threshold frequency set in the inverter, what is the line impedance, can we explain? So threshold, see all the Solis inverter, when it has been manufactured and dispatched to customer, they have been set it by default in IEC 61727 grid code. And as per the IEC 61727 grid code, the voltage, the frequency window is between 49.5 to 51.5 hertz. That's a frequency window, and if anything frequency going beyond that range, inverter will going to stop working. What is the line impedance, can be can so line impedance is nothing but the kind of a resistance which is there in the in the cables, or in the distribution point, or when the distribution point, if it is able to deliver the power, consume the power, and further if it is going towards grid point. So all the transmission line from the source to the export point, all these cables, we need to calculate the resistance. Like if the cable resistance is too high, too high, then this will be indirectly transferred into a line impedance problem, and inverter would see this, and inverter will try to overcome this line impedance problem. And if the line impedance is not getting overcome by inverter also, it will going to be disconnected in an over voltage alarm. Does this dip in power output power curve during the grid over voltage significant increase in reactive power? So as the Gagan has raised this question, so this particular problem, we can define. So as we have shared in today, that there are several working modes, and volt, watt, volt, var, and so we can specify we can set those function in inverter to make sure that it works whenever the such kind of situation is happening, like voltage is getting raised up. So you can also program the inverter to supply reactive power in the line. So like VQ, there are parameters, so we can program it in the inverters. What if the phase sequence change from the grid side? The phase sequences doesn't make any much difference to our to Solis inverter, as far as they are not the same phase. If they are in a reverse direction, also inverter will going to work with properly. Like is it is anti-clockwise or clockwise, doesn't make much difference. As far as all the phases should be 120-degree phase angle should be maintained. So please explain how the unbalanced load will result in UNGV error. So unbalanced load doesn't actually make much because whenever the inverter is actually in operation, they will be producing balance output. Irrespective of your loads are in a balanced condition or unbalanced, or they are like one particular phase is completely occupying 5 kilowatt of power, and another phase is completely zero. So but when the grid tied system is in place, so the complete grid connection is acting as a load. So a solar inverter will always going to generate a balance output, as far as the voltage is not going to be changed between two lines. Like the tolerance is like if the tolerance is more, if the difference is more than 20% between line to line, then only inverter will going to show this particular alarm under voltage grid. Otherwise with the same voltage and unbalanced load condition doesn't make any impact. How to know or find out the right grid standard on a particular area? I think you can refer the user manual. Sankalp Singh, you can check our user manual where we have specified in which particular menu you can able to see this information. Mr. Rajeshwar has said why nighttime power reactance is required by few discom. Basically, nighttime